All right, I'm going to do 3 things right now and hopefully be done with this in no more than an hour. First, I'm going to go over the 2 problems I gave you on that pre-test that I said you wouldn't have to do. And then yesterday, Luke came up and asked me a question about one of the homework problems, and I could see where there would be some confusion, so I'm going to do yet another one of the homework problems with you for I think it's chapter 8. All right? So, we're on schedule. Again, tomorrow will be the hands-on test for chapters 6 through 8. Thursday, I'll go over the test, and whatever time is left will be lab. Friday, we're going to start something new. We'll see how that works. All right? Maybe I'll give you lab Friday. We'll just, like I said, we'll see how it works. All right. So you were asked to do 2 problems. And again, these problems are not different, not very different from what's on your test tomorrow. So in just a second, I'm going to go through this array fun thing, which is a console program that has a menu, and it uses constants. And, you know, if you enter a 1, it does this. If you enter a 2, it does this, etc. I'm not going to read that to you. All right, so we'll go over that one. Let's go over that one right now. And again, I've said this kind of thing to you before. When I write something, that doesn't mean it's the best way to write it. By no means does it mean that it's the only way to write it. All right? But what you were told here was to create an array with 25 elements in it. So the first thing I did was to make a constant, called it array size, and set it equal to 25. Also, as mentioned in the textbook, that if you're going to be changing the value of the array, and we're going to change this one, we are, that if you're changing the value in the array, that really you should not define it in any method. It should be defined outside of any method. So that's what I've done. All right. My question for you is, does this make sense to everyone? I'm going to generate 25 random numbers between 1 and 100, and I'm going to put them in here. Does that make sense? Then I'm immediately going to copy them into here, because that's going to hold the numbers in their original order. That's the sole purpose for this array, is to hold the numbers in their original order. Why? Because that was one of the things that we were asked to do in the different menu options. Other than that, we wouldn't have needed this. All right. So here's main. This is all of main. So what has been done there, when you look at it, we've declared one variable that I called menu choice. I didn't even initialize it. I could have. I didn't. But if you look on the screen, I am putting this into an infinite loop, which is going to tell you to keep calling these until sometime in that loop you enter a 0, which says stop the program. Does that make sense? All right. Then menu choice is going to be equal to display menu. Guess what? That's this thing. We talked about this before. That is just enter a 0 to do this, enter a 1 to do this, etc. That is its job, is to display that menu. Then it clears the screen and it says, okay, what are you choosing? You are told to choose a number between 0 and 8. Okay? I want to make sure we put in a number, and if we did, we want to make sure that number is between 0 and 8. If it's not, we just write 8 out of range. And we ask them to do it again. Does all that make sense? So what you're going to see, because I'm going to run the program in just a few minutes, this is going to bring up a menu that's, this is going to bring up a menu that says, put in a number between 0 and 8. 0 to end the program, 1 to generate an array, etc., etc. So it's going to tell you to do that. Then it asks you to enter a number between 0 and 8. Unfortunately, not everybody can take instructions. So someone may put in a number that's less than 0 or that's greater than 8, or may even put in something that's non-numeric. So we're going to check and first make sure it's numeric. And if it is numeric, we're going to make sure it's between 0 and 8. If it is, that becomes the menu choice. So we want to keep you stuck in here until you call this and you put in a value between 0 and 8. That becomes your menu choice. Does that make sense? Then this says call correct menu or call correct method. This will be put into a switch. It says if you entered a 0, quit. If you entered a 1, do this. 2, do this, etc. So again, this display menu, there shouldn't be any surprises here. You should all be able to take a look at this, and it should make sense to you. We've done enough things like this. Now, remember, it's different if it's a GUI program, correct? Because if it's a GUI program, you've got a lot less control. So if it was a GUI program, then what you have to do is if they put in a number less than 8 or something non-numeric, you'd have to handle it in that way. Write out a message box or something. All right? We've done that before. So again, asking you to input your selection, verifying your selection is numeric. If it is numeric, verifying it's within range. If it's not numeric, that's when the else will be hit. Notice I give you an error message. I do a read line just to stop. Then I call the whole routine all over again. This one. So I'm forcing you to put in something that is within range. So again, if I run this and I put in something non-numeric, all right, this is what should be hit. Non-numeric menu choice made, please re-enter, and it should show this all over again. Hello. Non-numeric, please re-enter. I hit enter, boom, it comes back again. All right. If I put in a number that's either less than 0, so a negative number, or if I put in a number that's greater than 8, this should run. So again, it should say out of range. It should do a read line to pause. And when I hit enter, it should display, call the routine again. So if I put in here 37, out of range, less than 8 or greater than, less than 0 or greater than 8. All right, menu choice made, please re-enter. Boom. And it cleared the screen and it did it. If I put in a negative number, same thing. So what this is looking for is for me to put in a number that is within range. All right. The is numeric, nothing new there. This MC just stood for method choice, or menu choice. If it's a 0, this tells you to quit the program. Environment.exit 0. How did I find that out? I Googled what's the best way to end a C# console program. And this was the one that they suggested. Just so you know, technically, and I don't get an error for it, but technically, that line in blue can never be hit. Why? Why can't that line ever be hit? You already exited. Very good. But I put it in there for completeness. All right? So if I enter a 1, I'm telling you to generate a new array. We're going to look at all these in just a minute. If I enter a 2, show the array in original order. If I enter a 3, show the array in ascending order. If I enter a 4, show the array in descending order. All right? If I do a 5, if I show it in ascending order, the one on top is the smallest. If I do a 6, if I do it in descending order, the one on top is the smallest. If I do a 7, I add the array elements. If I do an 8, it's the average. If it's a default, if I put it, that should never be hit. Line 116 should never, ever, ever be hit. It should be impossible. But if it happens, I'm just breaking. Okay? So, how do we generate a new array? All of these routines, at least in my opinion, are nice and compact. What is this doing? All right, it's generating, basically it's creating a new instance of the random number class, and it's saying generate 25 random numbers. put each random number into the numeric array, and then copy what you just put into the numeric array into the original array. You didn't have to do this, but when I was done, I just generated a line that said, new array has been generated. You didn't have to do that, but just to show the user. So again, if I run this, and I put in a 1 and hit enter, new array has been generated. So that routine has just run. Does that make sense? All right. If I generated 2, I want to print out the array in original order. So what does that mean? When I wrote this, I tried to not repeat code when I didn't have to. So notice I'm telling it to print out the array. What array? The original array. So I've got one routine that prints out the array in original order, prints out the array in ascending order, and prints out the array in descending order. Does that make sense? Because you're doing the same thing every time. So one of the things you should be striving to do now is if you don't have to, don't print any more than you have to print. All right? Remember, when you print in ascending order, it's an array.sort. When you print in descending order, it's an array.sort followed by an array.reverse. One thing we did not go over in class, but I would like you to read, because I forgot to go over it, we can look at it in just a couple minutes, is how to use that binary sort. With that binary sort, that assumes that your array is already in ascending order. So if I give you 7 numbers, if I say to you, is this number in there? You know it's not. You're not the computer. All right, so if you've got 7 numbers like this, you go in the middle and you say, is that the number? Well, no, it's not. Okay, is what I'm looking for greater than this or less than this? It's greater. So I already know those 4 numbers have been removed from consideration. So now I look and I cut it in half again. And I say 82. Is that the number? No. Is it greater than or less than? It's less than. So those 2 numbers have been cut. So the only number that it could be is this one. So it checks that. It says it's not that number. It returns -1 because it says it isn't there. You will be asked tomorrow to do that. So I would say if that confuses you, all right, either look in your book because she gives an example, or go out to MSDN, Microsoft Developer Network, msdn.microsoft.com, and put in the search bar by C# binary search, or just Google C# binary search. All right, so I've generated a new array. Now, I want to call this, I want to print it out in ascending order. So it should do an array.sort. First, before I even do that, let's print out the array in original order. That's a 2. So that's the array in no order whatsoever. But you should be able to look at that and say, well, it looks like 100's not in there, but 99's in there. So that when I go put it in ascending order, it ought to be at the end. When I put it in descending order, it ought to be at the beginning. It should make sense to you. I mean, you could do this by hand. It would be silly to do that, but you could. All right? So I'm going to come in here and I'm going to put it in ascending order first, which is a 3. And again, you'll notice that 99 is at the end. So now when I put it into descending order in just a second, it should just be flipped. You know also now that 0 is the smallest array element. You know that 99 is the largest array element. All right? So I come back in here. Now I want to put it in descending order. So I put in a 4, and there it is. Then I want a 5 for the smallest array element, which is 0. A 6 for the largest array element, which is 99. A 7, which should add all of them. And when you think about it, there's 25 elements. An average element size should be about 50. 50 times 25 says the sum should be somewhere around 1,250. when you do it, somewhere around there. It's going to be higher or lower. It's very rarely, if ever, going to be 1,250. All right? So now when I look at this and I do an 8 for the average, an 8 for the average, it's pretty close to 50. That's the way that it should work. So if you go and create a program like this, you should be able to tell. Now you notice I've got a bunch of flags and stuff in here, and that's just because I didn't want to run the same code over and over and over again. All right? So what that did, this number that's here says you're about to print out the array in original order. The 2 says you are about to print out the array in ascending order. The 3 says you are about to print out the array in descending order. That's what those numbers are. That's it. All right, and there it is. Now, if this thing here that says flag, you might look at that and go, what the heck does that mean? What does that mean? Flag. What are you doing with flag? Well, here I want to print out the entire array. Here I want to print out the entire array. All right, etc. But down here, do I want to print out the entire array? Do I have to sort it? Do I have to manipulate it? And if I do, it's true, and otherwise it's going to be false. All right? And again, I'm not saying, well, this is really easy or this is really hard. You'll notice that mine is still around 220 lines. You are going to create something similar to this, and I'll even go as far as to tell you, but it'll be GUI. All right? So you should be able to take something like this and make it into a GUI program. All right? So that's the first one. Questions? All right. Then the second one that you were supposed to do said create a C# console program with 3 parallel arrays. Now you'll notice there's 3 arrays. First name array, last name array, test score array. Since they're parallel, they will all have the same number of elements. Does that make sense? That's the parallelness. Also, it says each array should be 10 elements long. Well, when you're testing it, and that's what I'm going to show you is when I tested it, I made it only 3 elements long. Because I didn't want to have to type in 10 first names, 10 last names, and 10 test scores. All right? You will have an example tomorrow where you will be, it's a console program, but you will be creating parallel arrays. In fact, that one might be a GUI also. I don't really remember. All right? So let's look at this one. So again, there's the comment. Here's the array size, so yours would be 10. All right? But I just made it 3 for now, so I only have to enter 3 names and 3 scores. This is the minimum score somebody can have. This is the maximum score that somebody can have. The idea, though, right here, those are the parallel arrays right there. The data type doesn't matter. The name doesn't matter. The size does matter. They're parallel. What does that mean? That means that I can have one loop and I can cycle through all 3 arrays. That's what I want to do. All right, so in main, I've got 2 variables in here. This is a Boolean. Run program again. So as long as I want to run the program again, which I do when I start, I clear the screen, I fill up each array, go back to that in a minute. Then when we're done, we ask if they want to do that again. That do again thing that's right here, that's asking you whether or not you want to do it again. So if you look here, and I'm going to make this nice and small, sorry, but if you look right there, that's main. Main's not doing really any processing. It's declaring a couple variables, but inside of a loop, It's telling you to fill the array, or each array. All right? Determine the low test score, determine the high test score, determine the average test score, ask the user if they want to do it again. Main is becoming more and more a driver. You should not be doing processing in main. Main should be calling routines. A good main is like a good supervisor, where she or he knows how to delegate authority. Does that make sense? All right. I've said this before. I've had supervisors that have been fantastic, and I don't really sometimes realize what they do until they're gone for a few days on vacation or whatever. Then I'm like, wow, now I know what you do. All right. So let's look at this. Here's fill each array. It's too big to put in there. So what do we have? Well, this is going to fill up the 3 arrays right here. This should make sense to you. All right? This tells you to enter the first name. This checks to make sure that there's something in there. If you didn't put in a value for the first name, it keeps you stuck in there until you do. All right? And that would work whether it was done in a GUI program or in a console program. And I'm going to show you that. I'm going to run the whole thing in a minute. This is a little shorter program, so I'm going to run through all of it. Then finally, when I get to here, I put a valid value in for the name. Okay? Then I do the same exact thing with the last name. Could I have written just one, could I have written another routine and called it twice? Yeah, that might have been better to do. All right? And then we tell you to enter a test score. And the test score must be between 0 and 100. So we tell you to enter it. We check to make sure it's numeric. If it is numeric, we convert it and we make sure that it's within range. If it's not within range, we give them an error message, and we're going to basically ask them to do it again. Otherwise, we've now got a score in there. All right? Is numeric. We've done this too many times and we don't have to even talk about it. All right, I put a debugging thing in there. Why? Because when I first ran this program, it wasn't giving me the results I was anticipating because I had a logic error. This routine right here, I left it in, and what it's doing is while I'm filling up the array, it's printing the stuff out. Now, this, give me the lowest test score. All right? So this says if the test is less than the lowest test score, all right, set it. And then this, it's kind of confusing. It's possible that more than one person had the same bad test score. Maybe 3 people were missing that day. All right? So they all got zeros. So 0 up here is going to figure out the lowest score, but then this is going to say who got that low score. It could be 1 person, it could be 2 people, it could be 10 people. All right? And then I print that out. Then I do the exact same thing for the high score. Now, I want you to realize this. Please look up on the screen. When you're checking for a low score, it's less than or equal to. When you're checking for a high score, it's greater than or equal to. Some of you on your homework, you use less than for both of them. That's wrong. You lost points. All right? Then the average is pretty simple. We add up and figure out the total points and divide that by the number of people who took the test. So again, when I ran this, I only put in 3 names. All right? Just because I didn't feel like typing. But it worked fine with 10. So I'm going to run this, enter the name of student 1. All right, I got a 56. Enter the name of student number 2. She got an 87. And then let's enter the name for student number 3. And John missed class that day. So you got a 0. So, notice scores 0 for the low, 87 for the high. The average, which is 56 plus 87 plus 0 divided by 3, is there. If I run it again, and I say, for student, let's just say student 1 got a 0, student 2 got a 0, student 3 got a 1. The 1 is the highest. But now you can see I've got multiple people who have a low score. And you can see what the average is. Does all that make sense? Because you are asked to use parallel arrays in the program tomorrow. All right? I don't even think there's any calculation you have to do. You're searching for things. But the idea is, can you understand the way to use parallel arrays? All right? And again, if you say, well, I'm not really sure, then go and try to do this program. All right? That's why I gave it to you. All right? And you know what? I feel for you. When you say, yeah, but you already give us enough freaking homework. Yeah, you do. All right? But especially if you've been struggling with tests, it probably would be in your best interest to go back and try to do this. Nothing else. You kind of got a cheat sheet for tomorrow. All right? Now, I'm going to give you a break, but right before we do, let's see, it's back up. Was that chapter 7 or chapter 8, the one that you had the question on? 7? Okay. And you know what offhand what number it was? That one. All right, so after the break, I'm going to go over this one with you. All right? I'll go over that one. I want to make sure people understand the way that's supposed to be done. So I'm going to create the convert miles to kilometers program. So let's take a break. It's 9:16. Let's come back, please, at 9:30.